Well, welcome. Today is Friday, May 16th, 2025. This is the BMC study group, and we're just going to begin. So today we're going to look at the head glands. What did you guys find interesting yesterday?
Hmm.
Or is there anything you want to talk about? Or
Hmm.
I have a curiosity of just find it like very central, the pineal gland and the pituitary gland, and I would like to palpate it and really get I know where it's located, but just like where does one want to locate?
it's above the brow.
Mhm. Because it feels very
Pituitary,
central.
pituitary is on the bridge of the nose.
Mhm.
Yeah, so pituitary, you draw a straight line through here, through your ears, from here through your ears, and from the center down, and you'll get to the sella turcica. Do you remember that? When I'll bring out my skull. Would you like to see it on the skull as best you can? Do you remember what the sella turcica stands for?
No.
Sella means saddle, and turcica
So,
means Turkish.
Turkish saddle.
Yeah.
Hmm.
Yes, exactly. So it's the pituitary sitting in a Turkish saddle. So I've never been in a Turkish saddle, but because of the skull, I can imagine what it looks like. And here it is. I'm going to use the other end. This is where it
Mhm.
sits.
Hmm.
So if we turn it from the side, you see if I can't pin this, just to pin this.
Yeah,
Let's see.
yeah.
Oops. Doing something left-handed. Let me see. I want to put it speaker view, speaker view, speaker view. Okay. So as long as I'm speaking, it stays here. But I want you to feel free to talk. So we'll play with it. So here is, what's the name of this opening here?
Hmm. I don't remember what that
So
is.
that's that foramen, which means hole.
Oh, right. Oh, right.
This is the
Foreign.
foramen magnum, and magnum means big, great.
Right.
That's the biggest hole in your skull. And
Mm.
why is that so big?
Because of the spinal cord,
Because the
right?
spinal cord rises up there. Yeah. We have other openings, the nasal cavity,
Hmm.
uh, the ear canal, the eyes, holes behind the eyes, the sinuses here, the nasal passages here. Looking for the concha. Just to orient around the bones here. You can't see inside the nasal passages. Oh, you can see that. Yes, you can.
Hmm.
What are these called? These are the concha.
Mhm.
These are like open tubes, like a snake shaping S formation. So the air gets filtered or cooled down as you breathe in. And if you've ever gotten lost, you can, or do it yourself. If you feel you need to open up your nasal passages, or you want to check for your deviated septum, you can stick your finger right up your nose and all the way in the back. Have you ever done that?
No, I don't want to do
No. It's I would say eye-opening, but I would say it's ear-opening.
Yes.
If you have some latex gloves, you can stick your finger right in there and really open that passageway up. It's very helpful at times. Okay, so pituitary sits, let's use this orange color here. And here's the bridge of your nose. So put your hands there. And on this model, it's just in front of the ear canal. So it'd be just in front of your, yeah, that's it. And remember, you have the anterior pituitary, which grows from the roof of the mouth. And the posterior pituitary, which goes from the anterior portion of the hypothalamus. And then so one is coming from the roof of the mouth, and one is coming from the hypothalamus. And they fuse with the infundibulum, which you can study on the handouts that Bonnie gave us. You can see Rathke's pouch separates from the stomadeum, and the pouch and the infundibular process join together. There's a part called the pars tuberalis, encircles the infundibular process. And then they form the posterior pituitary and the infundibulum. But the Rathke's pouch forms the anterior pituitary. And that's on your handout. And here comes Ava. And what do you know about the pituitary? We're just getting started, Ava. How are you?
I'm good, thank you. Glad to be here.
Nice to have you. So the pituitary gland is referred to as the master gland because it interacts with so many other endocrine functions and glands and tissues. The endocrine glands that it touches, and not touches, but stimulates, are the thyroid, the adrenal, the gonads, the mammary, meaning the milk glands, and the fat. The organs, the pituitary has control, or not control, but stimulates, connects to, communicates with, are the liver, the kidneys, and the uterus. And so as you go through puberty, your pituitary activates some of those growth hormones. And in the brain, the pituitary is related to the hypothalamus. And the hypothalamus is regulating autonomic function. Pituitary affects physiological functions of the glands through secretion, absorption, and responses. It affects growth and development. fluid balance, metabolic functioning, reproductive cycles, childbirth and lactation, and your stress response.
Lot.
It's a lot. It's a lot. Oh, I love that yellow outfit on you, Eva. It's so pretty.
Thank you.
Yeah. So the energy center is the bridge of the nose. That's for the posterior position. And the center of the forehead for the anterior pituitary. So we can take a minute again to try to locate these structures. I can feel the anterior pituitary right away. On the posterior pituitary, I have to go back behind the anterior one portion. I go back behind it and I find that. So body feels that the inner vision comes from the posterior pituitary, and the anterior pituitary has to do with outer vision. And in terms of time, sense of time, has to do with foresight. So if you know somebody who has great foresight, they probably have a strong anterior pituitary lobe. So what we can play with right now is differentiating and integrating and balancing between your insight, your inner vision, and your outer vision, and your movement. So you're going to play with balancing between the internal and the external vision. And do you remember what the next gland is? Glands, or what's above them?
Pineal.
The mammillary bodies come next. So you're on this diagonal, and what's above the mammillary bodies?
I know.
The pineal.
Pineal,
Yeah.
Yeah. So the pituitary gland connects through the mammillary bodies to the third eye of the pineal gland, so that the past, the present, and the future are all active in each moment now. It's pretty fantastic, isn't it?
Mhm.
So let's find movements now. Just, you could take a simple walk, and you can try to isolate different lobes. And then bring them together. You can take a walk around the room. I'm very comfortable with the anterior pituitary, very comfortable with outer vision and forethought. And then if I drop back, it's different. It brings me more inward to be in the posterior lobe. For me, I feel like my distance is no longer long distance, but it's going inwards. Are you more comfortable in one than the other, or you feel like you're comfortable in both? Take the time you need, and then you can come back to the camera, to your screen. So what did you notice? Excuse me. Okay, jump right in, guys.
I think, when you are in the anterior, it's you, as you said, would drop back. It's hard to actually then to share from that place. I
The anterior? Anterior?
no, the posterior.
Okay.
I mean, I definitely feel it's like it removes you a little bit. It
Yeah.
removes me a little bit, yeah.
Yeah.
Um, and then I started thinking that, where in life I used that a lot, like, like in improvisation, I felt like there was a constant, like an outside eye, like how would the audience perceive? Because timing and you can have the greatest time with whatever you're dancing, but then the audience might get bored. So I learned, or to put an outside eye on and then an inside eye, and so feeling it, like what felt right. And I feel that has to do with that, and then the outside eye, how is the objective time more? That
Hmm.
don't make any sense.
Yeah.
Mm-hmm.
Mm-hmm.
And then the pineal is, I realized I never thought about this way, but that's when I connect with my higher guides and with my spirit beings. Um,
So
yeah.
we'll go into the mammillary next, but
Oh, I kind of you mentioned it already, so it was like there also like
I see. I see.
Hmm. Okay, that's
Okay. So the pineal, the pituitary gland connects through the mammillary bodies to the third eye of the pineal gland. So we have the past, the present, and the future all active in each moment. So let's look at the mammillary bodies. And let's see if I can find something to show us. Huh. Well, here's a nice one from Gil Headley. Do you know who that is? He's the anatomical. He's such a great, I had the great fortune of being in his workshop. Within September, he did something in New York, but he's been dissecting the bodies of people and has a whole lifelong practice of honoring the people that he's dissected and being in close communication with the families. And many of these people that are dissected donated their bodies. And he's got a whole website. Have you ever heard of him?
Yes.
Okay, so it's somebody to put on your list of important people to know about. And here's a video, and we'll see what he has to say. Can you see this?
Mhm.
Okay, so I'm going to turn off my headset.
I have been teaching a pituitary and pineal gland meditation, which is really sweet. And I thought I'd share it with y'all. But first, you have to learn a little bit of the positional anatomy of the pituitary and the pineal gland. I'm going to start with the pituitary because you got to start somewhere. So
Please see the whole page.
You can, you
Just
want, okay, I'll open it up. And just so you know,
yes, there.
I haven't listened to this, but I don't think he mentions the mammillary bodies. So we'll come back to the mammillary bodies.
So the pituitary gland, bunk, right there. See the little green dot? That's the pituitary gland. Now, do you see there's an X here? X marks the spot. That's the optic chiasma. Now, the optic chiasma is the pathway of the optic nerves of your eyeballs as they cross over behind themselves. So you see how the skeleton has cones, a very cone shape here for the eyeball, and there's a kind of a hole in the back. The optic nerve passes through there at an angle, right? Because the two eyeballs are in these cones, seated in these cones, so the nerves cross over each other like this. We call it the optic chiasma, and beneath it sits the pituitary gland. Now, another way to get to your pituitary gland, where does it sit? It sits, I should draw it in, let's put it, it sits in the sella turcica, the Turkish saddle of your sphenoid bone. So it has a nice little pocket there. It's not just dangling in the wind. It's seated in a pocket, the sella turcica. So you follow your optic chiasma back, or your optic nerves, and where they cross, X marks the spot, you'll find the pituitary gland seated in the sella turcica. Now you'll notice the bridge of the nose actually seats here too. So if you go to the bridge of your nose or the bridge of his nose and you go straight back, basically, at the midline, and then drop down into your sella turcica. So that's another way to find it. But also notice the soft palate here. If you take your tongue and follow the hard palate, soft, go straight up from there. And there's what's called the sphenoidal sinus of the sphenoid bone, and then the pituitary gland. So 3 strategies for finding your pituitary gland. Follow your optic nerves back to X marks the spot and drop down. Follow your bridge of your nose straight back and drop down into the sella turcica, or bring your tongue to the soft palate and go straight up. This is a way to sort of a three-pointed approach to finding your pituitary gland. What I'm going to ask you to do now, and if you're doing this with us at home and joining us here in our studio, just sit down. Right, and in a relaxed position. Doesn't have to be fancy. But do sit down so that if you're going to close your eyes, you don't keel over. Right, so we want you seated for this exercise. I say don't do this home, but I want you to do it home. Just seated. So come with me inside your somanauts, and you're going to navigate your inner space here by basically just following back through the cones of your eyes to where the nerves cross over, and you'll be right over your pituitary gland, or follow the bridge of the nose straight back. And don't do this with thinking, but do it with feeling. Actually sort of feel your way back there. And finally, you can go rise up through the soft palate and triangulate these different spots. And what I want you to do with me is actually notice the quality of sensation that you feel when you pay attention to this place in your body where your pituitary gland lives. You might notice particular qualities of sensation that surprise you, or that sort of leap out to your attention as you just kind of hang out here in this place. It's in your body, so it's yours to feel. And just gently hang out there. Notice the qualities of sensation in your body that are particular to the place where your pituitary gland lives. Let your eyebrows be soft. And then bring your attention back to the room. You can continue to feel the sensations. And with your attention in the room, you might say, oh, I felt such and such a way, or such and such a way. I'm not going to tell you what you feel. I'm not going to plant any ideas in your mind, but just allow yourself to add to your inventory of self-knowledge the quality of sensation that you notice when you hang out with your pituitary gland. Now we're going to add the pineal gland. Where is the pineal gland? Well, this is a self-portrait, by the way. You like it? So the pineal gland I have drawn right there. Where does it live? It lives in the back of the third ventricle. It has little feet touching the thalami on each side of the brain. The thalamus here is this little round part here. That marks the interthalamic adhesion. We're looking at a cross-section. This would be the corpus callosum of your brain. This would be the neocortex. And here we have our lateral ventricles. So the pineal gland sits at the posterior aspect of the third ventricle, which is kind of the negative space between the two thalamus tissues. And you can see the fourth ventricle here, anterior to the cerebellum, with the aqueduct of Sylvie passing the cerebral spinal fluid through the ventricles here. And notice how if you were coming up from the spine, you'd be sort of splashing like a ball on a fountain, the pineal gland. Now, if we drop straight down from the crown of the head, the high point of your head here, you come into your pineal gland. It's absolutely in the middle of the sagittal section, right? So it's in the middle plane along with the pituitary, directly down from the crown of your head. Another way to get to your pineal gland, well, we can't see the ears here, but if you went to right here on your ears and kind of went straight in and met that midpoint from the crown, right, in the sagittal plane, you're going to come, might be a little above the cartilage here, a little above the cartilage, right? There you go, a little above the cartilage. So here's the cartilage. We got to get up a little bit. Maybe it's more towards the top of your ear. Now that I think about it, yeah, it's kind of more towards the floppy part of your ear, and you go straight in there. And another way to access your pineal gland is to go back to your pituitary gland and to do kind of a back dive, because the pituitary is about 2 inches forward and a half an inch down from the pineal. So you kind of draw an arc between the two, see? Like that. I like to say it's literally like doing a back dive. I'm the pituitary and I'm reaching for the pineal. Okay, so let's go there together. Okay.
Okay, so he doesn't talk about the mammillary. So if you want to play, you can play with that arc. In my mind, I see this diagonal line, but it's fun to think about this splashing that he's doing and the arc backwards. So just keep in mind, there's lots of ways to reach things.
Our pineal gland, if you just settle in again like you did, be seated and allow yourself to follow the pathways I just described. You might drop down from the crown of your head like a plumb line or a pendulum down to your pineal gland. Or you could also kind of go like we described from the tops of your ears here, your ear cartilages, and follow your way into the center. Meet up with that midline again. Or you could just remind yourself of the feelings you felt when you visited your pituitary and kind of arc up and back from there, and you'll find the pineal place. And as you do, just notice what surprising qualities of sensation you might feel there, and maybe there's distinct sensations particular to the place where your pineal gland is, as opposed to your pituitary. And again, it's not a thinking process, but a feeling process that brings you into this space within yourself. And notice the quality of sensation when you pay attention to that area. Now you might add to this as you enjoy that sensation that you can actually kind of reach forward from your pineal, forward and down towards your pituitary. And as you arrive at the pituitary place, you can kind of pause for a moment and then arc back. And you can actually create a sensation relationship between your pituitary and your pineal gland, just kind of arcing back and forth between the two at a very gentle pace that allows yourself to actually generate within you a combined sensation characteristic of both the pineal and the pituitary. A combined sensation characteristic of both the pineal and the pituitary. And you can actually create a sensation relationship between your pituitary and your pineal gland, just kind of arcing back and forth between the two at a very gentle pace that allows yourself to actually generate within you a combined sensation characteristic of both the pineal and the pituitary. Now, this is an exercise that you can do by yourself or with friends or silently while you're working with a client who may be on your table and you're holding their head in your hands, and you can go to this place in yourself and find yourself and training your client to a very deep and peaceful place within themselves. It's a nice way to do service, actually. It's a nice way to create an entrainment that's very positive and enriching. It's nice to know where your pituitary and pineal are. And if you're back in the room with me now, you might be aware of the quality of sensations that are still present to you, not just lost in an internal world, but this can be present to you in our common environment. And again, I'm not going to tell you how you feel.
Okay, so good. You've got an exploration. Now, he moved in an arc, and we're going to add the dragon tail. So we're going to add the mammillary bodies. So now you have the arc from the pituitary to the pineal. But let's go into between the two places. You have the mammillary bodies. So science hasn't caught up to Bonnie yet. They call it mammillary bodies and not mammillary glands. but it's in the middle portion of the ancient forebrain. If you have your pictures, you can look at it. It's behind the hypothalamus from which it originates. Its center is at the top of the head, as Gil pointed out. That's a birthing crown, if I believe. And it's a continuation of the central axis of the spine. So find your central axis and go up. You're going to go behind the pituitary, just behind the pituitary, as you see on the diagrams, and then up to the top of your head. And that's your mammillary bodies, which have to do with presence. But in traditional texts, they're referred to as nuclei. But we think of them, they vibrate. All the glands are vibratory, and these function as glands. The Bonnie called them guardians of the perceptions. And they're related to your smell and your taste. And the time is present. It's present time. You know, whereas the pituitary was what? Forethought. Mammillary is present time. So in your mind's eye, you can adjust yourself too, but let's think about adjust yourself between forethought and present thought. The mammillary bodies engage both sides of the body, whereas pituitary is only one gland, one in the center. So the mammillary bodies engage both sides of the body and the brain into a single focus. And this one moment is of no space, no time, all space and all time. Far out, I'd say. That's far out. So you can connect to the downwardness, reaching down to the coccygeal body through your dragon's tail towards the earth. As the mammillary bodies reach upward toward the heavens, opening and balancing the energy, passing in both directions through the inner central channel. And you could take that image and walk around with the dragon tail reaching into the earth and the brain reaching up into the heavens through the mammillary bodies, and see how that makes you feel. Quite a dance. No space, no time. And all space, all time. About smell and taste. And if you want to, you can play with going to the pituitary, then to the mammillary, forward to the pituitary mammillary. And you can find if you continue on the diagonal, you can find the pineal, which we'll get to in a few minutes. I love the mammillary bodies. I have a very strong smell. Oh, that's a smell. Don't forget the dragon tail, how you can wrap that around your body. Really continuation of the spinal cord and going all the way up to the mammillary bodies and out to the heavens. Going down the central channel into the tail, to the coccygeal body. So remember, the mammillary bodies rise from the back end of the hypothalamus. Hypothalamus meaning below, under the thalamus. And they begin to form during the 4th week from the ventral portion of the hypothalamus. And by the 8th week, they are a pair of swellings and continue to grow and differentiate during the fetal period. Remember, the pituitary has to do with vision. Mammillary has to do with smell and taste. And the mammillary bodies, the presence is the presence. There's both, there's no time and no space, and all time and all space. That's your now, the now.
So is the mammillary body, is that like in the sinus? Is it like above the sinus? I'm trying to
Are you talking about the
understand.
nasal sinuses?
What?
You're talking about the nasal, above the nasal sinuses?
Yeah.
Sinuses, yeah, because sinus is a term for a lot of different places. Yes. So if you look at the structure here, your nasal sinuses are here. You
Right.
have pituitary here, and then you're going to go on a slight diagonal up. So you're above the sinuses.
Right.
We can't look inside. Just, yeah, there.
Okay.
And remember, there's one on the left and there's one on the right.
Right.
There's only one pituitary and one pineal, but they have
Right.
2 mammillary bodies.
I'm wondering, my mom lost her smell after a flu. And I have a friend who fell off a horse and has done, I don't know what, but she can't restore her smell. So
Have you worked with her to restore her smell?
I've worked with her spine, but I did not know about the connection between the mammillaries and smell. So I will say again.
Maybe you can play with her sense of smell.
Right. So if she can connect back to her mammillaries and see, and yeah.
But actually use sense, smell to take different things and teach them to smell them. Sometimes you have to reteach the sense of smell, especially
Done that, it has not it has not. I mean, she has done things like that that has not had any success.
Well, that doesn't mean she won't be successful with you.
That's true. That's true.
You're a special person, so.
Hmm.
Here, let's look at this Gray's Anatomy. So you can see this picture portion of the screen. You can see this.
Mm-hmm.
So here's the mammillary. Here's the posterior lobe and the anterior lobe of the pituitary in the sella turcica.
Right. Okay, there's the saddle. Okay.
Yeah, okay, that's nice to see. Yeah,
That
right,
looks really much too big, but it's way
Right.
down. Hypophysis is another way to say pituitary. And then if you go on the diagonal back, you'll see a mammillary body on this side. And here would be your sinuses, Andrew, down here.
Hmm.
Okay, here's your basal artery. There's your pons. Mammillary body. Here's another sinus, a circular sinus inside here. Here's your optic chiasma.
Mm.
So this is the crossing point of your eye optic nerves.
Mm.
Drop down into the chiasma or cross into the chiasma. Your lamina terminalis. I don't know if you took the brain course. We have the anterior commissure.
I did, but I forgot.
Woo!
Mhm.
This gives you a good idea. Let's see if we can find another one.
Okay.
Right, and mammillary bodies is recollective. The function that is associated with it is the memory. So memory information is with hippocampus. The theta waves activate the CA3 neurons in the hippocampus. Information about memory transmits through the fornix to the mammillary bodies. As mammillary body damage results in memory impairment, but not amnesia.
Oh, that's interesting in terms of, I'm seeing my mom getting older. She doesn't have dementia, but her memory is, she remembers, of course, things from old, but not the daily things anymore. Because you said no time and space, and I was like, that's interesting. If it's memory, then there needs to be time and space. I don't understand that.
It's true. There needs to be time and space. But shoot, it's interesting to look at that. I'll come back. In our notes, it has to do with smell. So they don't mention smell in the brainstem, the mammillary bodies and the brainstem nuclei. See what they say here. Ken Hub. Can you see this?
Did you know that the weight of your average human brain is approximately 1.4 kilograms? That's 1,400 grams. What if I told you that one little part of your brain, weighing just 4 grams, or just 1/3% of your brain, is a vital epicenter for your hormone production, behavioral patterns, and involuntary or subconscious body functions? It's the part of your brain that helps tell you when you're hungry or when you need to stop eating, when you're thirsty or perfectly hydrated, when you're sleepy, or perhaps chiefly wide awake. tells you when you're feeling chirpy or just plain grumpy, when you're feeling all loved up or just not in the mood. It's also responsible for releasing your inner beastly rage that you never knew you had, setting off your internal panic alarms when you're getting stressed, thirsty, or perfectly hydrated. It's the part of your brain that helps tell you when you're hungry or when you need
Just
of
wanna
your
make sure I
brain is a
understand.
vital epicenter for your hormone.
Which part she's talking about?
4 grams, or just 1/3 of a percentage of your brain, is a vital epicenter for your hormone production, behavioral patterns, and involuntary or subconscious body functions. It's the part of your brain that helps tell you when you're hungry or when you need to,
Generally
when you're thirsty.
talks about,
What was that?
I think she just generally talks about that epicenter of all these glands together. She
Well,
didn't
no, she's talking
specify.
about the hypothalamus, the hypothalamus.
Yeah.
Oh, the
Perfectly hydrated.
hypothalamus.
I'm sorry?
Okay.
Okay.
Yeah.
When you're sleepy, or perhaps chiefly wide awake.
We'll
Tells you
see.
when you're feeling chirpy or just plain grumpy, when you're feeling all loved up or just not in the mood. It's also responsible for releasing your inner beastly rage that you never knew you had, setting off your internal panic alarms when you're getting stressed, and even getting you pumped to fight an approaching enemy. This structure that I'm talking about here is none other than your hypothalamus, this small structure right here, which packs a mega punch when it comes to controlling your hormone production, bodily functions, and behavior.
So I don't see anything mammillary related there. So it's interesting. Let's stop the share. So we felt the connection of the coccygeal body, the dragon's tail, toward the earth, as the mammillary bodies reach upward toward the heavens, opening and balancing the energy passing in both directions through the inner central canal. So now you can integrate the mammillary bodies with, we're going to go into the pineal and the pituitary glands on the diagonal between the nose and the birthing crown up here. So let's go up to the pineal.
The birthing crown, that's the fontanella.
Yes,
Okay.
it's a little, it's where you put your, if you were Jewish and wearing a,
Oh, okay.
if you were wearing a yarmulke.
Okay. Because just languages, I'm just like thinking like I wonder what that is in German, but yeah. Okay, but I know where it is.
That would be interesting to find out.
Yeah.
It's in German, yeah. So the posterior portion behind the thalamus is called the epithalamus. In a groove where the two halves of the thalamus join together, above the superior colliculi of the midbrain, and beneath the posterior portion of the corpus callosum is the location of the pineal. So I guess we should find that so you have a clear understanding location of the pineal. That'd be helpful. Let me go to pineal. Okay. So it's an endocrine gland in the posterior aspect of the cranial fossa of the brain. And connect this. Its importance is in the circadian cycle of sleep and wakefulness. The pineal gland is also known as the epiphysis cerebri. The gland is pine cone shaped and about 0.8 centimeters long.
Pine cone shaped. Oh.
It's big enough to see. It secretes melatonin, which is what helps you sleep at night. See the thalamus here. This is the insert here. This is a bigger picture of this area. Here is your pituitary. Here is your hypothalamus, this diagonal. They don't show the mammillary bodies, but the mammillary bodies would be in the middle between those two. Going straight back, you have the pineal gland here. So there's your diagonal.
For the arching backwards.
Yeah.
Can you see this picture?
Are you looking at a picture? Are you
Yeah,
showing something on the screen?
I mean, in this image, the mammillary bodies are closer to the pituitary gland
Mhm.
in terms of like,
Are you
they're
looking at the picture I showed you on the screen?
relatively closer than the pineal.
Just so you know, everybody's brain is different, and you can find it on yourself and see if that's true for you. I know
Right.
the picture you're referring to. You haven't told me what picture you're looking at yet. Are you in
Well,
a
I'm just looking
book?
at this. It's the complete human body. It's second edition, the visual body. I was just trying to get some other images to
I
look
think,
at.
yeah, I'm looking on my phone and I'm seeing also the mammillary bodies right under the crossing of the eye, the nerves of the eye. This is a cadaver. And so that would confirm, Andrew, what you are saying. They're closer to the pituitary.
Are you looking at this anatomy book, Andrew?
I'm just going to look at that one right now. I was looking at another one, but I was just going to look in that on this one right now.
Yeah, it's helpful just to keep looking at different things. I tend to rely on the Netter's book.
I have a cadaver image here.
In your own brain.
Sarah?
They don't even have.
You guys have the Netter's book? 4th edition?
I don't have that.
So I have a cadaver, like a image of, you know. And if the crossing, they seem to be very close to the crossing of the eye nerves.
Yes. Well, he didn't talk about it, and Gil didn't talk about it.
No, but I mean, then the crossing, the pituitary and the crossing are very close to the mammillary body, seem to be very close to that too.
Yeah, here's a nice picture of the brain in the Netter book. And plate 106. I can get a full picture of it. We'll change the view to speaker view. Do you see the freestanding one in the bottom here?
Oh, okay.
So what does it say?
Core body of form, columns of fornix, cura of fornix, body of fornix,
Cura fornix.
formation of fornix. Is that the one that you want to show us?
Yes, you want to see, I want you to see. I can't read it upside
Oh,
down.
there. Yeah. Mammillary bodies. Just go a little bit up, Sarah. Go a little bit up. No, that's, yeah. Mammillary bodies. amygdala, yeah. Bodies and
Hemicloidal
compass.
body. Hippocampus.
These are the mammillary bodies, no?
Yeah.
Yes, yes.
And what are these
Oh,
two?
I see. Oh, that's really helpful to see that because
Yeah, that's
I didn't understand how they were connected. I thought
yeah.
you were saying they were separated, so I was just thinking of them separate.
They are
So
separate.
that
One
they're
is left and one is right.
I know, but what I'm
Yeah, but
saying
there's a
is they're
crura.
not, but they're connected through
Here.
the
Yeah,
columns of fornix. That's what I'm saying.
Yeah.
that's so cool. I didn't know that.
The crura of the fornix, the body of the fornix, the commissure of the fornix. And these are the amygdaloids, amygdala,
Right, yeah.
amygdala. Boy, they have a funny
Amygdala.
spelling on it. Those little drops are the amygdalas. And the hippocampus is the bottom of the loop. That looks like a good view.
Yeah, yeah, yeah.
You can see that.
Yeah.
Oh yeah.
And you can see it.
Amygdaloid bodies,
Say that again.
are the amygdaloid bodies then also glands?
No,
Okay.
I mean, you know, the amygdala is what is your fight or flight response. So,
Right.
and you know that they're secreting hormones some sort, but they're not considered they're not
Glands,
considered
okay.
glands.
I guess that's why the mammillary bodies are also not considered glands, right? I mean, from the medical.
They're nuclei in the medical, traditional medical.
Yeah. Yeah. So
The
then what do you call the amygdala then?
amygdala, it's part of the brain structure.
Oh, brain structure, but I mean, like, it's not gland, is what?
It's a brain structure. It's like the hypothalamus. What do you think of the hypothalamus? What do you call that? It's a brain structure.
I thought that was a gland.
We don't separate it out as a gland. It secretes a lot of hormones for sure.
Okay, well, that's confusing. Okay.
Yeah,
Good.
I mean, that's an interesting question for consideration. You've got a lot of different chemicals that are being secreted from different parts of the body. What makes a gland versus the amygdala? I can Google that right now and see if they give us an answer. See. Is the amygdala part of the limbic system? It's a small almond-shaped structure inside your brain, and it's part of the limbic system. And the other parts are the hippocampus, the thalamus, and the hypothalamus, the cingulate gyrus, and the basal ganglia. So let's go visit this. And we'll put you on.
Oh. And again, we wonder sometimes, I mean, thank God there is Bonnie, but anatomy, the way it was called back then might not be what we think about it today.
Right. So the limbic system consists of this fornix, which you were just looking at. They kind of put this all together, the anterior group of the thalamic nuclei. Here's a mammillary body here.
Okay.
Here's the
Okay.
hypothalamus. Here's the amygdala, which has a lot to do with your fight or flight response, your fear response.
Uh-huh.
And they don't mark it, but this is the pituitary, this red
Right.
bulb.
Okay, yeah, okay.
And then if you go on this diagonal,
Right, a little bit diagonally up, and that's the saddle underneath there that we see.
this is the what underneath?
But the saddle, the Turkish saddle.
Turkish saddle. You don't really see the Turkish saddle. Oh, you're talking about the greens. This is a
No.
soft tissue structure. The Turkish saddle would be holding the pineal, and you don't really see it.
No, the pineal. This is where you are right now is that's the pineal. I thought that thing is the Turkish saddle. No, that's just the
No,
pineal.
no, the Turkish
Okay, got
saddle holds the pituitary.
Okay.
Turkish saddle holds the pituitary, and it's a bone. Let's see, you can't see this. I'm not going to take off the share. Share is so pretty. So you have the cingulate gyrus on the outside.
Uh-huh.
You have the hippocampus in purple. You have thalamic nuclei. You have this fornix, which we were just looking at. It has a wonderful shape.
That's it, yeah.
Down. And you have the corpus callosum around the fornix. Which separates the hemispheres.
Oh,
Right.
And what is this structure?
The
That is the cerebellum.
cerebellum, yes. Yeah.
And then what is this structure?
That's the no, how is it called?
It's the brainstem.
Right, but that goes all the way down to the tailbone. I mean, to the sacrum.
Yeah, once it leaves the skull, it becomes the spinal cord.
Yeah.
But there's some little bit of it is still the brainstem, and then it goes down into your spinal cord. To your tail.
And the spinal cord goes to the the middle part of the sacrum, correct? And then that's a different, again, they call it.
Right, you have the tails, this different structure. You have the place where your spinal cord ends, and then
Right.
you have these different nerves coming in at S2, and you form the pelvic
Part
pit.
of And that's the lower part of our dragon's tail.
Yes, it gives root to the
Yeah.
dragon tail. And let's just jump to the carotid bodies, because we didn't talk about it. And you know where your carotid arteries are, right? So you can trace your own carotid arteries.
Bless you.
And see if you can find the bifurcation between, if we want to go there to the tumor, let's see. The carotid body works as a sensory organ made up of different receptors. It lies where the carotid artery divides into external and internal branches. They receive information about the blood's oxygen and carbon dioxide levels, and they help regulate the respiratory rate and blood pressure. And each carotid body lies within that bifurcation. one on each side of the upper neck at the vertebral level of C3 and C4. The energy center is at the top of the neck between the first cervical vertebrae and the skull. And the reflex point is the tip of the neck between the first cervical vertebrae and the skull. And it's a chemoreceptor. It measures the balance of oxygen and carbon dioxide passing through the carotid arteries to the brain. And the carotid body supply energy to the spine, which is the tail of the inner neural organ of perception. And they open the passage into the brain, which is the head of the inner neural organ of perception. And a movement exploration, you would add the parathyroids and the ribs to the movement of the arms spiraling along the horizontal axis. And the carotid bodies provide the foundation for stillness and silence. I just love that. So let's do a little exploration where we're putting our fingers on the carotid.
Sarah, just if I need to leave, I have the same thing like usually I'm gonna be just going, and next week I'm traveling on that day, so I will not be able to join.
Oh, I'll miss you.
Yeah, but I will, I actually need to send you money again. I will see the recording. Yeah, so.
Thank you. Do you see this picture here? Are you able to see the photograph?
Uh-huh.
Okay, so can you find your carotid artery? And can you travel up? It's just the bifurcation for most people is just below the hyoid bone. So you can feel your hyoid bone. You can see here is your jaw. Here's your hyoid bone. And going back, if you can dig through your glands, around the top of what would be the thyroid cartilage, there's a bifurcation. It becomes the internal branch of the carotid artery, and the external branch stays on the outside of the neck. The internal branch goes into your skull, and it forms the circle of Willis, which you may or may not know about. I happen to know about it because I had a study called an MRA to study the blood flow. And I got to see what was happening with my internal carotids and the rest of my brain. Very interesting.
Wow.
Wow.
Here's the artery traveling up your vertebral column through those foramens on the outside of your vertebrae. And this is what gets damaged sometimes with a rough chiropractic adjustment that can be torn.
Oh,
So you need to know that your chiropractor is quite experienced, and don't let anybody just twist your neck around without knowing what they're doing. And then it's interesting to feel if you can find the carotid body and find the stillness. I feel a very strong pulse there.
Yeah.
Okay. Thank you guys for coming. I'll just hang on. So I know that Ava has to go, but if you have more to say, I love that stillness.
I just put a link to, I think, Netter's book, but it's I think it's more specifically neuroanatomy and neurophysiology, which it has like personal study, you can like look at these images.
Wow, wonderful. Thank you. You can scroll down and find I'm scrolling down.
Yeah. Yeah, just
Okay,
think-
so I'll share this again.
I just copied it. Thank you, Sabrina.
yeah.
Wow.
So here we have pituitary gland. Here we have the mammillary body. And here we have the pineal. So it's wonderful to be able to have a sense about your pineal gland, your mammillary body, and your pituitary. Here you have the corpus callosum, which separates the right and left hemispheres. This is the pons. Here is your medulla oblongata. And this would be midbrain. Let me see, that's labeled. Here's the superior colliculus, which has to do with your reflex to respond to sound visually. So you turn towards the sound. That's your superior colliculus, and your inferior colliculus has to do with the auditory. You hear something that you turn towards it. One is visual, one is auditory. It's amazing to me that that exists. Posterior commissure, pineal body, posterior commissure, habenular commissure above it. This is the passageway between the two hemispheres. I'm sorry, between the two ventricles. This is the anterior commissure. And here's the lamina terminalis. So when we talk about the primitive streak rising up to the pituitary stalk, becoming the lamina terminalis, which Bonnie feels gives rise to the rest of the brain.
Mhm.
Thank you for that link. That's very helpful.
Yeah, that's wonderful. Thank you.
Yeah, you're welcome. Mhm.
Right. Okay, guys.
Okay,
So nice to be with
it's
you.
wonderful. Yes,
My head is full of dreams
yes,
and visions. And I'm resting on the stillness.
yes.
Carotid bodies. Much
Yeah.
love. Ava, I will see you next time, whenever that is.
From Germany.
Have a
Oh,
wonderful
from
trip.
Germany.
Yeah, it will be late at night, but I think yeah, it will still work. How long are you still doing the course, Sarah?
I'm not sure. I think probably we'll stop, but I don't know if there's a lot of people that are asking me to continue, then I would continue. But we'll see.
Oh,
You let us know.
All right, my
thank
love.
you so much.
Thank
Have a
you.
great day, great
Wonderful to be
weekend,
with you.
everybody.
Thank you.
Thank you.
Bye.
Bye.